So we start with the next episode on train, which is the twins. So these two local trains that you see in this are twins. Now what is being said here? We understand type phi by this, yes, but what is type phi? Train crossing another train, both travel in the same direction. Is this a repetition? We have done this before. Train crossing another train, both are traveling in the same direction. That was our type 3, which we understood by the example of Rajdhani Express. But what was given there was the distance between them is 0, which means the engine of Rajdhani Express is touching the last bogie of the local train. The distance between them is 0. But now what is given here is the distance between the two train is given to me. Let's move on to this. Yes, these are twins. The distance between the two train is given, and that's what makes this type different. Two trains are there, yes, they are traveling in the same direction, yes, just like your type 3, but in this case I am being given the distance between the two trains. And what is being asked to me, when will this train catch this train? Now this is also important. What is the meaning of catch? This train came here, time has started now, this train is going and it just catch, that's it. When will this train catch this train? The question is not when will this train completely cross the another train. Then it would have been type 3. Completely cross means crossing its length plus crossing its own length. Crossing the length of the another twin train and crossing its own length. That would be a crossover, right? But that is not the question here. When will this train just catch this train? It means you will have to come to type 3 and stop. Right, Rajdhani Express just came, it was somewhere else, let's keep it here, it was somewhere else, it just came and it just caught it here, and this is where you have to stop, and you have to stop thinking other than that. So make sure what you are supposed to know in this. When will the first train catch the another train is the only question that I have it here. See, for crossover you will also need the length of two train, which will not be given to you in such kind of problem. So obviously then it's a type 5. You're just being asked when will the first train catch the another train and not cross over. So remember this, catch and crossover. Now what is being said? A fast moving train is trying to catch, very important, a slower train. The speed of the fast train is 150 km per hour, okay, and this distance between the two train is 450 kilometers. As I told you, the distance between them will be given to me, which is nothing but 450 kilometers. This is given to me. It takes 5 hours for the faster train to catch the slower train. So I start my stopwatch. It takes 5 hours for this train to come here and stop. So in 5 hours, it travels 450 and it just catches this train. So that is something which is given to me. Find out the speed of the slower train. Okay, so I'll start with my basic formula. The only formula I know here, time is equals to distance upon speed. Time is given to me as 5 hours. In 5 hours, what is the distance that is being traveled by this train? Because this train is supposed to catch this train, right? So I'll just compare everything from the point of view of this train. So distance traveled is nothing but 450 km, correct? Speed, I need to write the speed of this train. Ideally, if this was stationary, I would have just written the speed of this train as train crossing the bridge. I hope you remember that, type 2. But what is happening? This train is moving and this train is also moving. So this train is moving subtraction of this speed. What is the speed of this train? Fast train is moving at 150 km per hour. If this train was at stationary, I would have taken the speed as what? 150 km per hour. If the first train was stationary. Right? But what is the thing? It is not stationary. So it is also moving. And what do we write the resultant speed then? It will move by 150, correct, in 1 hour, 150 km per hour, but it will be subtracted from the speed of the next train, because the next train is also moving ahead by certain hour in certain kilometers in 1 hour, right? So x kilometer per hour, let that be the speed of this train, because if this is moving by 150, I would have written 150 if it was stationary, the first train, but this is also moving, so it is actually a subtraction of 2 speed. And if you just want to know it by simple way, 2 trains traveling in the same direction, you always subtract the speed. Okay, and because you are thinking of the speed of this train relative to the speed of this. Relative to the speed of this. Right, and that's why if this is moving by 150 kilometer in 1 hour, but this is also going ahead by something, so as a resultant, when I relate it with the speed of other, you will say, okay, if this x is say 100, if example, it will move 150 minus 100, it will move resultant of only 50. Okay, that's just an example. That's just an example to let you understand. Okay, I hope you get the point to why I subtract the speed. This is actually not 100, so this is actually not 50. This is just an example to let you know if this was the case, this would have happened. Now let us just find it out. We already know the answer now. Now this is the plot that has been given to me. Let's cut this. This is 5 ones are 5 nines are 45 0. So what comes out to be here? 150 minus x is equals to 90. So x turns out to be what? 90 minus 150 is nothing but 60. That's it. So the speed is nothing but 60 kilometer per hour. That is the speed of the next train. So that's how you get the plot for it. As I know everything is in kilometer hour, yes, so I'll get it in kilometer per hour. So now you can say if the speed of this train is 60 kilometer per hour, which means what will happen in 1 hour. Now imagine a case. This is speed is 150. The distance between them is 450 kilometers, and the second train is here. The speed of this is nothing but 60 kilometer per hour. Now imagine what will happen in 1 hour. What will happen in 1 hour? The speed of this is 150 kilometer per hour. This will go ahead by what? This will go ahead by 150 in 1 hour. But this will also go ahead by what? 60. This will also go ahead by 60. So resultant, this is moving to chase him what? 150 minus 60, because this is also moving. So resultant, it is moving only by what? 90. Okay, and that's how you get it. If you want to imagine a scenario, see, this train catches this train in 5 hours. So 150 kilometer per hour, how much will it travel in 5 hours? 150 into 5 is what? 15 5 is 750. So it will travel a distance of 450 plus 350 more from here. It will travel, this is 350 more from here. Correct? 450 plus 300, sorry, 300. 450 plus 300, it will be 750. What will this train travel in 5 hours? Speed is 60 km per hour. So 60 into 5, this train will travel 300. Check it, it's the same 300. This train will travel 300. This train will travel 450 plus that additional 300, such that this train will travel 750 and this train will travel 300. So this 450 which this train was supposed to cover, it will cover, and it will cover additional 300 which this train has traveled in 5 hours. Okay, such that a total of 450 plus 300 it will cover to catch this distance at a distance of 750 kilometers from this point. So if I say this point is A and they meet at a point B, what is distance AB? What is distance AB? That is 750 kilometers. So imagine a scenario and try and solve such problems. It is easier to know that when trains travel in same direction, you subtract the speed, but it is important to understand why it is called as a relative speed, because you relate the speed of the second train with the speed of the first train. If the first train was stationary, then you wouldn't have compared the two speeds. You would have just went with type 1 and type 2. Since both are moving, that is when you need to see what is the resultant movement of the second train with respect to the movement of the first train. And I hope the twins episode gives you a good visualization of why do you subtract the speed.